Thank you very much. Any questions from the audience? Yeah, there's a question over there.
Okay, this is just a comment for your information. I am working for IRADE, Integrated Research and Action for Development, last 1 year. And I am doing a project called SARI, South Asian Regional Initiative, under this program. And this project is looking into regional electricity trade in the South Asia. So main point is a country included in India, Bangladesh, Nepal, etc. For India's context, we have model, it's a macroeconomic model and engineering model. Engineering model is under Times framework. Yes. So they are hard linked. So of course, Times model has first it is a national model, not regional model. Second thing is it does not have, 15 minutes representation, but it has an hourly representation of operational aspect. And so these two models talk to each other. So electricity demand, which is macroeconomically consistent, foreign exchange availability, investment coming from macroeconomic model, going to the Times engineering model. And engineering model gives technology choice, electricity generation by technology choice, taking into account hourly availability of renewable sources, etc., to the macroeconomic model. So this is for your information. We have this kind of hybrid approach is being used in my institute.
Thank you.
And which is used for this SARI project.
Thank you. I am aware of the SARI project and the Times model also. Thank you.
And just a comment from my side before the next question comes. Are these models open source models, or are they publicly available? Because that's the same development that you have seen in Europe, like different institutes start to develop their own models, then they come to an event like this one, and they have like 4 or 5 different results, and then they start to fight about what is the right approach, and the industry sits there and saying, well, you all have the wrong data, so we don't trust you at all. And that's like the movement saying, well, you have to develop open source approach that you can really check and understand what is each other doing, and that the industry starts to also contribute by delivering data. I think that's quite important, and I think you should work towards this idea of sharing models, at least on the academic side. I think for consultants it's always quite difficult to do this, or for commercial organizations, but I think it will save you a lot of time. That was one of the, in my opinion, very painful developments in Europe, that too many single models have been developed and there was no joint cooperation in developing certain models to do their own research. But I think the research itself, outside of the established industry, is quite important. But I think you should combine and work on this one to make it open source.
Applications are going to be available, are already available in the SARI website you can get. So that's for your information. And that describes the modeling approach, methodologies.
Okay, there's next person, another question. Indradeep.
Hello, I am Indradeep from GIZ. Thanks for your nice presentation. I have a comment concerning the data availability. You mentioned about GIS applications and solar and wind time series, etc. Various institutes in India actually working in that. For instance, National Institute of Wind Energy in Chennai, they are doing with the wind and solar both. Already GIS platform, they have put up their Solar Radiation Atlas of India, which is 3 and 3 kilometer resolution. They are also measuring and monitoring high time temporal resolution series for both solar as well as wind information. And there are other institutions like ISRO, for example, or other meteorological institutions in India. They are all somehow collecting data and working, and they have cross linkages with each other also. Apart from that, there are several instances of large projects happened. USAID did with NREL in India. So many interesting work on that, where they had to use kind of combined values from the time series in the GIS platform. Also, we from GIZ, we also undertook one study 2 years back, where we did the whole Indian 20 by 20 kilometer resolution time series analysis for both wind and solar. So my the main point is that it's not that nobody's doing something. There are many people are doing. There might be a need for kind of integration approach.
I totally agree. I was talking about academic perspective. For a student like me, it is very difficult for paying for the data. Suppose we want to get data from NIWE for every location in India. So the cost I have to pay for that is very high. So I cannot afford that for a student like me. So I have to go to the NASA website or the other foreign website which can give me free data. So for the Indian organization who are doing study on that, they should collaborate with the academic institutions such that open data is available to them. So we should not get into the fight from where I should get data, and we waste our time in researching that. But data should be readily available to us to do the research on the first day that I was talking about. Recently, okay.
You just have to make your account and from there you can get all the data.
Okay, okay. I was not aware about that.
In IntraDip, can we maybe put a link on the conference webpage? Because like if people read this or see this presentation on video in the next couple of weeks, that we can put a link on the webpage so that everyone can find these data that are freely. Okay, thanks. Any other comments?
Good morning. My name is Yatin Sharma and I am from Power Grid. You talked about that operational constraints are not addressed in planning. I don't think this is right because POSCO people is there, Mr. Janardhan, and POSCO used to publish a operational feedback report 4 times in a year, quarterly, and it is well being addressed during the planning. Based on that, augmentation and transmission line augmentation has been addressed. Second thing, you talked about 5-region model. If you refer the transmission planning criteria of CEA, there is nothing like that 5-region model. This is a geographical naming. You have to model, we have to model actually up to 220 kV label for each state for the whole nation. So there is nothing like that planning is done in isolation for a separate region. Third thing is that, yes, we are planning on deterministic approach, but we are slightly moving towards probabilistic approach. Final thing is forecasting. Problem is with forecasting, actually, if you see the 18th electric power survey, the demand for 2016-17 was predicted about 280 gigawatt. But now, as per 19th EPS, the demand reduced by 60 gigawatt. Now this is 225 gigawatt only. So planning was done for 280 gigawatt. Now the load demand is 225 gigawatt. So we have overplanned transmission system. Problem is that distribution system is not so much strong. That's why renewable energy, which is well connected at distribution level, is not reflected in the grid.
Thank you for your comments. So my point was not that the utility are not planning the system is very granular level. I know that the planners in the utility are doing very good job in doing very granular transmission and the generation planning. My only submission was that the planning objective that is given to them from the national level planners like Niti Aayog or Planning Commission, they first decide the capacity requirement. Then that value is given to the utilities to how to implement that policies. So where I need to put my new transmission line, where I need to put my new generator, like that. But how much I have to put, so that is always kind of decided previously. So I was proposing that the planning done by the national scale, it's as a course modeling paradigm. So I was talking about the improvement at that paradigm, not at the utility scale. I know it is already very high sophisticated models like optimal power flow, etc. are being used there, I know. And regarding forecasting error that we are talking about, the demand, it happens because we cannot predict everything in future, but the amount of reduction in demand that you are proposing, that I think it is unlikely, but I need to revisit. Means why such error in demand calculation took place. I think I need to see it properly.
Okay, thank you.
Okay, any further question? There's one.
Good morning, everyone. I'm a postgraduate student from Delhi University. My name is Sahana, and I would like to thank the panel for such an amazing session. I have a question for the panel, actually. We have been discussing about long-term scenario planning, but what would you consider as an ideal duration or a time frame for long-term scenario planning? Are we planning for 5 years, 10 years, or 20 years? What do you call actually as a long-term scenario planning? What is the duration? Thank you.
From a European perspective, yes, we are moving further ahead, and we have a close eye all the way to 2050. For what I presented earlier on, we were showing scenarios to 2030. In the next development of planning, our scenarios will take us also for the decade out to 2040. And some people may say, for instance, with this fast change in Germany on PV, that this is too much uncertainty. But indeed, we then make sure that the scenarios we cover have very large ranges of differences. And therefore, transmission, which may have a 60-year life or whatever, of that sort of order, is appropriate for at least half of the time, if not for the full lifetime, and is cost effective in that context. So we would say minimum 15 years, and scenarios that are very different, with different components in it, so that you look at the robustness, not just a single scenario, but multiple scenarios, and how well your plans will work in the different scenarios. And if I could just add one other thing, we talk about models and difficulties in sharing models. In Europe, NSOE has worked very hard over the last 5 years to get interoperability between models. We have 41 TSOs which use different software tools, and we have overcome that by tremendous amount of work for power flow, as well as dynamic model sharing, which is exceedingly complex. And this has now been adopted a week ago or two by IAC as a worldwide standard for interoperability between different systems for electrical studies. Thank you.
I would like to also comment on your question, because I think every country on this planet is running out of the CO2 budget within the century. And I think if we talk about long-term planning, we have, each country has to set a target to say, when will we be finished with reaching our target? Yeah? And that sets the point in time until which you term your long-term planning.
And if I could just reinforce the message that we had previously from Professor Hoffman of all energy. It's no good just looking at electricity. So in UK, for instance, we've just got about close to 10 years now of doing all energy, and increasingly the interaction between the different parts, and particularly between our gas sector and the electricity sector is very, very big. And so how the electricity operates will totally determine the load patterns on the gas network in the future. So the interoperability between those are strong, as well as with the transport sector increasingly with time. So heat and transport linked in, as it was earlier ignored in some of the countries' studies, but it is essential to gradually build up that capability.
Maybe just an additional comment. My experience is that for policy discussion, like 40 years looking ahead is quite important, looking at different scenarios. But don't make the mistakes that politicians really care what happens in 40 years because they're only elected for 4 years. But I think for the general discussion, it's quite important, and also for the different stakeholders. We have heard from NCE, it's really becoming standard now in Europe that you have a large number of interested stakeholders being part of this discussion. And that's something I'm still trying to understand in India, who's actually involved in this discussion and who's framing this discussion. But for this kind of discussion, 40-year scenarios or different scenarios, it has become very, very important to really understand the complexity.
Okay, I add developing countries' perspective, whereas Europe is transforming its energy infrastructure and building low carbon pathway. Situation is different for developing countries. They are building their infrastructure, and most of the countries I am visiting, they would be dependent on large infrastructure like LNG, nuclear power plant, coal power plant, etc. And all these big project, it takes itself 5 to 10 years. To get financial closure itself takes, I think, 3 to 4 years. So taking into that, and then if you add construction time and etc. Taking into that, I would say 20-25 years planning for developing countries would be important. And what I see now, they are looking into that. Earlier, there used to be, many of the countries used to do 10-15 years planning, but they are now going ahead. Like Bangladesh has made 2041 planning. So they are looking into in a longer perspective. Things are changing there. Thank you.
Okay, I think we can take one last question, then our time is up.
So I wanted to only add a couple of points to what the panel said, and I totally agree to that long-term planning. So I was part of this offshore wind project where at the end of the day we found out that the states of Tamil Nadu and Gujarat being the richest in offshore wind potential. So the way the country planned for green energy corridor, it coincided with the onshore wind in Tamil Nadu. So onshore and offshore wind potential regions are the same, pretty much the same. So the GEC corridor lines, they can be used for the initial takeoff quite easily in Tamil Nadu, while it's just the opposite in Gujarat. So the onshore and offshore wind rich regions are totally opposite. The green energy corridor was planned in 2012, I believe, to accommodate onshore. While now, if huge amount of offshore wind is going to penetrate, then the takeoff could be a little difficult in that state. So had, long-term planning was done longer enough, like to include future scenarios like new emerging technologies, what if those technologies come in, then maybe this could have been addressed by the policymakers. So I just wanted to say that I totally agree with the panel on this.
Okay, thank you very much. I really enjoyed the session. It was an experiment. We didn't know when we planned the second and third day how these kind of sessions will work here in India. But I think from my perspective, I learned a lot. I hope you also learned a lot. I hope you join me in thanking the 4 speakers. Now there's like a smaller piece. We have now a 15-minute coffee break, so we start again at 11:15. The speakers and presenters for the next session, please come to the podium. If you have to upgrade your presentation, please do it now. Thank you.